Judy Warner. Welcome back to this week's Ecosystem Podcast. This episode is for you RF engineers that need high bandwidth and high performance. I've asked Steve Hillerich of Samtec to join me and talk about glass core technology at the device level. Samtec is getting ready to go to the IMS show, the International Microwave Symposium in San Francisco in mid-June. And I wanted to give you a sneak peek of some of the amazing technologies Samtec will be showing there and what benefits it has to engineers like you. Now let's jump into our conversation with Steve Hillerich of Samtec. Hi, Steve. Thanks so much for joining us today. It's been a pleasure to get to know you, and I'm excited to share you with our audience. And today we're going to talk about glass core technology. So before we get started, why don't you introduce yourself to our audience? Tell us a little bit about your technology background and your role at Samtec.
Yeah, so I'm Steve Hillerich. I've been at Samtec 26 years. I'm an engineer, although I don't do much direct engineering anymore. Product manager for Samtec's glass core technology, which for Samtec is the tip of the spear technology-wise. And so my role is to help sell and promote, market it, talk to customers, and sort of act as an application engineer as well. And, to some degree, help drive, maybe what we should develop next and why and what's interesting and, what the market tells us.
Right, exactly. One thing I really appreciate about Samtec is that you are actually shaping product based on the feedback you're getting from the real world. So let's go ahead and jump into it. So let's talk about what you mean by glass core. And I know when I first met you, I was scratching my head a little bit because I always think of Samtec as, super high speed, high performance cabling and interconnects. And I never really thought about glass core as an interconnect. So why don't you unpack that for us?
Yeah, there's a lot there. The first point I think is that the customers are absolutely what drives pretty much everything we do. First and foremost, we're a service company. We've tried, and I believe we have, for the most part, become a technology leader as well in the last 10, 20 years. And to your point, that's led to the generation of a lot more high frequency types of cables and connectors. And how we get to glass, you step back about 15 years or so ago, and Samtec makes an acquisition of a optical engine company. And at the simplest form, if you know nothing else about how an optical engine works, it's a high-speed long-haul cable, so it fits very nicely into the catalog. But it is an active device. And so that was our first kind of foray
Okay.
into, microelectronics and active devices. And we want to control the assembly. So we start packaging these devices. And we essentially started working with external customers as well as packaging our own products. And really weren't trying to take over the packaging world per se, but listen to our customers, understand where the bottlenecks are for, say, next generation packages and such. And what kept coming up over and over again was that, if Moore's law is seemingly slowing a bit, that, as you move from, say, a single sensor on a substrate, which together on a motherboard makes an entire system, and you move to then multi-chip module type systems, that as we look forward, and we do have, silicon-based substrates but we're hearing that glass might be the next sort of generation of substrate that enables devices to continue down the path of miniaturization and higher frequency, which is the constant goal almost all the time of electronic devices. So we get into glass with the acquisition of a company that has a recipe for a TGV, a through glass via.
Okay.
And at the time, I think we didn't know what we didn't know. And let's trying to listen to customers, but take a bit of a gamble. And in the end, it ends with us sort of controlling the entire system, the entire creation of the substrate. How you drill a hole matters. How you fill the TGV matters. How you integrate to the RDLs, the redistribution layers matters. And so to end up with that complete metallized glass core substrate, it took us years to integrate and develop processes, but we've basically pulled it off. And in the end, I think we would argue that it is an interconnect. You know, Samtec likes to think at the highest level of the entire signal chain, from the way a signal moves out of a silicon die, through a substrate, through a board, into a connector, and into the other, all the way back through to the other silicon, a
Mm-hmm.
rack device. And
Mm-hmm.
so, as much as a connector or a cable is part of that interconnect chain, we think that the glass substrate is as well. It's just as close to the chip as you can get.
Yeah. So do you think of it as substrate or do you think of it as an interposer? Like how do you and how do your customers sort of think about that particular interconnect?
That's a good question. And the truth is, the difference between an interposer and a substrate is in the details. And, some of them call it one thing, some of them call it the other, but there are differences. We find that most customers are using it more as a substrate, mounting their die directly on it in a 2.5 or 3D stacking type of application. Um, Interposer, it's used somewhat as that. Really, the terminology, the lingo is a function of, kind of who we're talking to. I kind of
I see.
call it whatever you want. To us, it is an interconnect, you know. Uh,
Right.
but the way that the folks that are, say, designing connectors and cables and PCBs, they use one set of lingo, and the folks
True.
closer to the silicon kind of use another set of lingo. And so, depending on who I'm talking to, it's usually someone closer to the silicon. It's a substrate
Right.
generally.
Right. Well, it's an interconnect. Maybe that's the way that both of those types of folks understand it's really an interconnect. Okay, I at the risk of going down a really geeky rabbit hole here, what how do you metalize glass, Steve, especially if you're drilling vias into glass? Like I come from PCB world. So I'm hardwired with thinking about plating those types of substrates that have things that will bite and ways to metalize that. How do you metalize glass?
Yeah, that's the tricky part. And honestly, it's not even that the trickiest part is metallizing the glass. It's doing it in a way that's reliable, under thermal cycling,
Mm,
mechanical shock.
right.
But and the longer answer is that this part of the answer to this question, or a big part of it, is in this secret sauce, right? That we won't
Okay.
totally. But I can tell you, you're right. It's not a PCB. We're not using a mechanical drill, and it's very much closer to a semiconductor fab tooling set. The types of
Okay.
tool lithographies, the sputter tools. There are the drill
I
tools are
see.
lasers and chemical etchants to make holes, and sputter tools, and still plating tools, and then lithography. Um, but in a clean room, you wouldn't necessarily
Right.
have to put a PCB in a clean room. But what we found is that we can essentially find a lot of existing semiconductor tools, but
Okay.
the glass, being for a variety of reasons, one of which is that it's clear. Things like alignment become a little bit trickier, right? On maybe aligning a mask or something. So we've sort of had to repurpose some machines in some ways to some existing semiconductor equipment, in some ways, and change recipes to drill holes and fill TGVs and do it reliably. But that is the real trick. And I guess I would also add, beyond that, the other thing we've learned is that I think glass is a very fragmented supply chain right now today. I think the cat's kind of out of the bag on glass, and it's how it's going to be used. And I think we're at the beginning of something really big, not just Samtec, but the market. And
Right.
so, we've learned that all of those elements to create a fully glass core circuit board need to be
Mm,
controlled upstream and downstream. Today, if you don't work with us, let's say, and you wanted to end up with a similar product, you can go to the glass suppliers, and they want to sell wafers or panels, and so they'll even give them to you with holes in them. And then you can go to somewhere else, and they'll fill it with a TGV, and then you go to somewhere else, and you add the RDL, and you can probably get something that works, even though it's expensive and slow. But then once you start to thermally cycle it or mechanically shock it, that's when you really learn the constraints. And so for Samtec, it was important over the last 8 or 9 years to focus on integrating that all under one roof,
Right.
controlling everything from start to finish, that reliability is the trickiest.
Right. Yeah, and I imagine that was a steep learning curve, and obviously it took you a long time. So let's talk about things that our audience will care about. So that's sort of the foundation of here's what it is, here's what can accomplish. So tell us why glass and what are the performance or the speed, or I know that you work a lot in the high bandwidth area with this glass core technology. So what does it do for engineers, as you're out there dealing with, your own customers all the time?
Yeah. Okay. So the first thing I would say off the bat is that we are still learning, like almost daily, it seems like, of new reasons why glass matters.
Okay.
And which is exciting, and challenging at the same time. But the first thing in general is that it's a substrate for interposer substrate. It's generally a substrate, and so and back to the nature of miniaturization and higher frequencies, it's very fine features, very small features. The via diameters and trace and space of the RDL, they're much closer to what you could get out of a silicon die than they are a PCB. So you just start with size, making smaller devices with shorter signal paths, that are less lossy, kind of thing.
Mhm.
And then you move on to things like that it's very uniformly thick across the wafer, and it's very smooth and it's very flat. And so those are the kind of properties that lend itself to reliably 2.5 or 3D stacking, copper pillar attach or
Mhm.
thermal compression or even some kind of a anodic bonding or something. So everybody cares about those two things at first. Then, of course, there's always a CTE match to the device, over coefficient of thermal expansion of the device, of the glass of your choice, because glass is a family of products. It's not just one material type. How does it match your system and under what conditions? And then from there, what we've seen so far is that there are usually one or two other elements that really differentiate their widget. And it really comes back to at this point, if you don't need glass, you shouldn't use it. And that sounds like a dumb
Right.
thing for a glass guy to say, but the PCB and the ceramic world, it's pretty mature, pretty commercialized. So if you can get a PCB to work, you should use it. It's just cheaper. But
Right.
for our customers that we find wins with, it is part of the thing that differentiates their widget. Whether they have a new sensor or MEMS device or you name it, it really won't work like it should without some function of the glass. And so, beyond those first couple variables of feature size and such, usually it's things like could be the hermeticity of the vias. We do a helium leak check on our vias, and they are hermetic. And so, depending on your device and where it's going, whether it's maybe in the body or in space or whatever else environment, maybe that matters to somebody else. Maybe it doesn't. The big one we see lately is the electrical properties, and specifically when you consider a material set like fused silica or synthetic quartz, has an excellent dielectric constant, loss tangent, and we've got customers, that they're pushing well over 300 gigahertz, through the substrate,
Wow.
So yeah, and so now you're getting back to getting shorter signal paths that are less lossy, and then generally require less power because of all of that together, and so that's a big deal lately. Some for others, though, it's also sometimes just as simple as the clarity, the fact that it is glass after all, and that may offer sort of unique assembly methods that you couldn't consider with silicon and a substrate or interposer in a way, but the high frequency portion of it is definitely the fastest growing uh, section we find. And so, just to take it a step further, what we've seen is that you know customers have learned how to characterize our processes and these material sets very well electrically, and the modeling matches the reality just a spot on, almost unbelievable. So
Which is phenomenal, right? Like, when do you get that?
Yeah, that's right. And so, I mean, we almost thought there was some mistakes in the simulations for, because it just matches. And so, then it leads into things like reduced cycle iterations. You don't have to
Right.
get there is the first thing. But separately, and as importantly, or maybe more, customers have also learned how to embed passive devices into the glass substrate. So just using the patterning of the TGVs and the RDLs, they're creating whether it's a filter or a waveguide, and you could consider a crossover or a Wilkinson divider or, a capacitor even. And what they're finding is not only do you have a substrate that is small, that is low loss, that enables all these wonderful miniaturization features, but then they can also pattern embedded RF components into it rather than having them sort of discretely attached to the top of the bottom. And then you just continue even further. Now that your device has less component count, less assembly steps, lower loss because there's less of an interconnection through a solder joint or something else, and that specific area of the high frequency realm is honestly really where we see the most growth today.
So tell us a little bit, again, for our audience to give them sort of context of where this might be a win, right? Or something they need to look at. What are some of the applications as you deal with customers out there? Because obviously, this is like bleeding edge stuff you're talking about. So, what kind of applications are you seeing across your sort of your customer profiles?
Yeah, well, it's a little bit of everything. Sometimes the applications can be a little sensitive, of course, but
Right. Mhm.
it's like I said, often high frequency. Anything from sort of telecom to datacom, but the backhaul types of systems, that are pushing not just 6G, but thinking about 7G infrastructures. Um, through biomedical devices and implantable devices, and where miniaturization is key and biocompatibility is key, and is while implantable is least invasive as possible is ideal, um, all the way through handheld devices. You can imagine as things get smaller and smaller, maybe DNA sequencing or some device like that, which maybe you have to have a sample that you take back to a lab today, but tomorrow you could envision having this handheld device in the field where
Mm,
you could put the sample on the device and sort of measure the DNA from that, all the way through uh, layers of MEMS devices, where hermeticity of the vias matter, for some kind of mechanical device, and it's military devices, which we definitely can't talk about, but
right.
the variety of next generation sort of devices all over the place, and that's kind of really what we find is again back to if you can use a PCB, you should, but we
Yeah, absolutely.
yeah, it's the
It's yeah,
somebody who doesn't want just a little bit faster widget, they want
right.
get a whole generation.
Well, or they can't get there without it, right? So, obviously, you're adding complexity to your design and all of that, so, yeah. Um, well, to play the devil's advocate a little bit, as I think about, our listeners is who else is using this kind of technology, and how do you differentiate, say, what Samtec's offering with sort of the competitive landscape?
Yeah, that's a good question. It's fair. And the trick is that back to early, whether we were lucky or smart, we got into the space 8 or 9 years ago, and so we have a head start. And we're still learning, of course, but the competition's coming. So I think it is back to a few key things in that there's really only a few companies in the world that we know of really that have everything under one roof. Kind of all of the
Mm,
processes from start to finish. And again, that's a very big deal. But we also know that there's a lot of money and energy being poured into changing that. The competition is coming, and so and there's a sweet spot of volume for that matter. You hear about some companies that are pouring hundreds of $1 million into a large panel, glass panel manufacturing, chasing very
mhm.
specific markets. working on wafers. We work on 6-inch and 8-inch wafers. And, so the types of devices we target maybe are a little different than somebody who is targeting a more consumer grade end product, on that
Got
would
it.
require a glass panel.
Right.
Um, I do think it's only a matter of time though before we have more competition that has it all under one roof.
Yeah.
And for that matter, I really think the market is still figuring out what it wants. If you check the news and just kind of poke around on this stuff, you can get a lot of mixed opinions, about some certain companies are really excited about it and then they're not excited about it, and different formats of panels and wafers. I guess I would add one thing that's very different and matters for our technology is that the via shape is a straight walled, fully filled, and planar via. One of the most common shapes you'll see is an hourglass shaped via.
Mm-hmm.
And even when attempting to fully fill with a plating method, you can get a pocket in there, or you can get a little sort of groove in the top and the bottom. And essentially, when you start to do post processing, uh, you might have outgassing or liquids trapped in there. So our via recipe and technology is different. I'm not sure we'd know of anybody else doing it that way. But
You're getting dead end, you know, perform simulation versus performance. So to me, that says a lot. Like everybody would love to have that. So if you're there, I would say you're in a really good position. Um, Steve, I know that we're just a couple weeks away from IMS, which is going to take International Microwave Symposium, which takes place in San Francisco. In regards to this technology and maybe whatever else you want to talk about, what's going to be your focus, and what are going to be the fun stuff that you're showing off as we go into that show?
Yeah, so the fun point is that for the first time in a few years, we're kind of back to proactively selling this product. If you looked
Hmm.
around our website, it's kind of hard to find. And the truth of the matter is, we told our sales force to quit selling it a couple years ago because we have more work than we can handle. And so we've been running 24/7 shifts for years now. But we started an expansion to our clean room several months ago that we expect to be ready sort of towards the beginning of the next year. And these projects typically have a little bit longer gestation cycle than, let's say, a connector or a cable would. So now is a good time to sort of get back into the market, start to tell this story, proactively sell glass again. So yes, we'll
Mm.
be at IMS, and so we have a couple demos. Um, one of which tells a really cool story about the entire, like I described earlier, the signal chain from silicon to silicon. And so there's a demo we have that, is going to use a glass-based substrate to generate a radio frequency. And it essentially is going to travel through a variety of all of our connectors and cables and interconnects. And we're going to measure the signal at a variety of points and demonstrate, how our products, you know, work as well as they do and offer such clean signals through the entire system. The second demo that we're really excited to show at IMS is a phased array antenna module in the millimeter wave space. And those are kind of two buzzwords in general: millimeter waves, frequency
Right.
range, and phased array. But
Yep.
it's going to demonstrate a um, 3D stacked assembly with 64 die on it, and on one piece of glass, and all of the RDL, and how it generates the frequency with the antenna and the embedded waveguides. And we have some simulations to show, and then the reality of the device right there that's being measured real time, and all of the eye patterns and all that fun stuff. So that's going to be really cool. And I think that demo by itself almost tells the complete story. There's, like I said, there's much you can do with glass, but that tells the whole story.
I, you know, I'm a geek, so I really love your guys' demos because they're so like you can sort of see that end-to-end story, and you can see the measurement going on, and it's good eye candy. You guys do a good job with your demos, so
We have a
I
great
know.
marketing team. It
Yeah.
made me think of another really important point too. The end to end, as these systems are getting smaller and maybe even specifically faster, it's not enough anymore to just think about, the silicon. Then someone else thinks about the package, and then someone else thinks
Uh-uh.
about the system. You kind of have to consider the system holistically, and that's not easy to do. But you've really got
Uh-uh.
to consider the whole signal chain through the system, and I think that's maybe the biggest value Samtec adds on its entire portfolio.
That's how I came up with that it was that idea that I was observing that, caused me to come up with the idea that ecosystem
Yeah.
is hopefully in this podcast, I'm showing people their upstream and downstream stakeholders so they get that perspective. And this is certainly, a more novel, interesting side of that. So I appreciate you coming on and talking about us. I think last year, I don't know, I've lost track of time, but I know that one of the things that other members of your team were talking about the orange microwave cable. Is that something that you're continuing to do? And do you have any input on sort of where that is for our RF engineering audience?
It is. Sadly, it's not exactly my expertise. I know it is the next generation sort of waveguide cable, and tons of demand for it. I'd be lying if
Okay.
I told you I had the deepest knowledge of its, sort of performance and offering. But it will be also demonstrated at IMS, and we will have several engineers there who can tell you more about it.
Okay, I'll put the link in the because I knew that was a big part of other members of your RF team. I know they were really excited about that. So I'll just link it for our audience in the show notes. So, Steve, where do you go from this? From glass core technology? Um, gosh, it just
It's
kind of blows my mind how fast we're going and how quickly technology is moving. So, do you have an idea of where you're going? And then why don't you tell folks where they might be able to find you, either this glass core technology, either online or at IMS?
Yeah. So, you're right. It's amazing how we got here. And when I started at Centec 26 years ago, I would have never guessed, that we'd even be having this conversation. Um,
Right?
but really what blows me away as much as anything is it's not even just the glass, but it's what it enables. It's these end
Right.
applications that are, I mean, we may not have flying cars like they promised us in the 1980s, but some of the things we have, I would have never dreamed of. And
Yeah.
every day I talk to somebody who's got an idea or they have a widget in process and you just, um, sometimes scary, we jokingly say, maybe we're enabling the end of the world. I don't know,
Yeah, I know. I say that too. Like, well, for good or for bad, we're running headlong into this complete unknown. And I know, um, I've been around 30 years plus, and it feels like we're living in a science fiction movie. Like, I'm with you. If you stick around long enough, it feels like I would have never predicted this
Yep.
10, 20,
Sure.
30 years ago. It's fun.
Yeah.
But like you said, hopefully we're not building AI to kill us or whatever it is we're doing, but it is fun, and it is fun to see what engineers can do with these new tools. So, well, thanks for the conversation. Is there anything else you wanna talk about before I let you go? There's a lot here, but I wanna make sure we send our listeners to go dig that out.
Yeah, so, we'll be at IMS, booth, 1453 this year out in
Okay,
San Francisco, like you mentioned. The web page to find more about these products is samtec.com/GCT, Glass Core
okay,
Technology,
okay.
um, or just contact me, and we try to be easy to work with and straightforward, so if you reach out, I'll answer the call.
Sounds good. One last thing that I had on my notes that I forgot to ask you about is the process design kit. You want to talk about that for a second before I let you go?
Yeah, good call. So this is something we're still early on. We're very excited about. It's likely a year-ish before it's really ready for live action. But the point is, all of these glass core circuit boards are some kind of custom routing, right? Design. And so that's tricky, to put in a catalog, or for that matter, we're dealing with different material sets than customers are used to. Borosilicate, fusilica,
Right.
synthetic quartz, sapphire, right? And so while I can give them data sheets on the material properties and maybe some S parameter or electrical data from things that we've generated ourselves, how do you continue to push the envelope? And for that matter, how do you continue to accelerate the design cycle? And so we're working on a PDK, process design kit. And, where it lands fully is hard to say, but the goal is that if you're a designer and you want to utilize glass, that it's novel material with these novel methods, and rather than starting from scratch, you very easily will be able to pull in elements, filter, waveguide, whatever, into your design. And then, sure, maybe you got to work on some routing to some level, but we hope to even have little blocks of sort of virtual blocks of, routing chunks that you could sort of design a system, a substrate for your system much easier than you could starting from scratch
I
with
see.
some basic design rules.
That's
Mm,
cool.
Yeah. And then know it's going to work because the simulations do match reality so well.
Very cool. Well, thanks for geeking out with me today. It's been really fun to learn from you and learn about this technology. Um, Again, I will send our audience to the website that you told us about, and then IMS booth 1453. Steve, great to talk with you. For our audience, thanks for joining us today. I trust you enjoyed this conversation with myself and Steve Hillerich. Make sure you go check out the show notes. We'll see you next week. Until then, remember to always stay connected to the ecosystem.